achievers. Everything is possible to achieve if we are together. So let's start our lesson. We're going to learn on percentage yield. So what is percentage yield? So percentage yield is to measure the efficiency of a chemical reaction. That is, the percentage yield is to measure the efficiency of the chemical reaction. So percentage yield is to measure, so just to measure the efficiency of the chemical reaction. So the reaction has taken place, we measure the efficiency of it. So that is a percentage yield. So chemical, the efficiency of the chemical reaction, that is the percentage yield. Now, what is the formula we can use to calculate the percentage yield? So percentage yield is equal to, so percent yield is equal to what? So actual over theoretical. So actual over theoretical times 100. So that is the formula. So percentage yield is to measure the accuracy of the chemical reaction. So this is the formula we use, which is percent yield is equal to actual over theoretical times 100. That is the formula we use. Let's give an example. So this is the question. Example there, which is 30 grams of C3H8 then burns in air to produce 70 grams of CO2. So 70 grams of CO2. Calculate the theoretical and percent yield of CO2. So they want the percent for CO2. So let's see the solution. The solutions. So there we have said 30 grams of what? C3H8. So 30 grams of C3H8. Then also there it says produce 70 grams of CO2. So 70 grams of CO2. So now they have given us the equation, which is C3H8 plus CO2. So it burns in O2, then it produces CO2 plus H2O. So those are the product. So C3H8 plus O2, so they burns, they produce CO2 plus H2O. So we need to find the theoretical and the percentage yield. So first thing, you need just to balance this. So this is not balanced, but you need to balance. So here you have C3, here you have what? C, which is 1. So here we put 3. So 3 will be C3. Then H it has how many? Which is H as 8. This side H as 2. So we'll put 4. So C as balance and H as balance. We are remaining with oxygen. So oxygen is what? Which is 4 times 2, which is 6. And 4 times 1, which is 4. So 4 plus 6, which is 10. So this side is 10. And this side is 2. So we'll put 5. So if you put 5, then this side, so it is balanced. So that is the first thing. Then we calculate the moles. So how can we calculate the moles? So there we know in the question, which is they want to find the theoretical and what? And percent yield of CO2. So on CO2 they have given us 70 grams of CO2. So this 70 grams of CO2, that is the actual mass or the actual yield which they have given us in the question. So this is 70 grams of CO2. This is the actual mass or actual yield. So I want to find the theoretical yield. So this 30 grams of C3H8 will help us to find the mass using the mole ratio. So let's start. So moles. So I want to find the carbon dioxide produced using 30 grams. So moles. So let's start. So what is the formula for moles? Moles is equal to what? Mass over mR. So that is the formula, mister. So what is the mass? Mass have given us, which is what? Here. Mass have given us, which is what? 30 grams of CH38. So that is 30 grams. What is mister? So when you look at there, we go in the periodic table, you find the molar mass for C3H8. So we write here C3H8. So then you write like that. So H, which is 8 times what? It is 1.008. There 1 times 12 or 3, so which is 3 atoms of carbon. 3 times 12.01. Okay, so now let's calculate and then we add. There it's giving us 44.094, because if you multiply it, giving us 8.064, 3 times 4.01, 36.03, then it's giving us 44.094. That is the molar mass of mister. So now we will replace there, which is 44.094. Then we divide. So what is the answer when we divide? So 30 divided by 44.094. So it's giving us 0.68. So the answer is 0.68, which is moles. Now I want to find the mass. So this is the moles of C3H8. This is the moles. Now let's find the mass using the mole ratio to find the CO2. What is the mole ratio? So that is the importance of what? Of balancing the chemical equation, which is 3CO2. Here it is what? C3H8. So this is 1 to what? 1 to 3 here in our equation, which is 1 to what? To 3. So now we write. So writing C3. So C3H8. Then we are in the mole ratio with CO2. So which is 1 to what? To 3. This is the mole ratio. Then we have calculated the moles for CH3, so which is 0.668. There is what? X. So we cross multiply. So this will give us what? 6 times 0.68 times. So what is the answer? So 0.68 times, which is times 3, 2.04. So there are 2.04. That is the moles for CO2. So we are getting the moles for CO2. Then we find what is the mass. So mass is equal to moles times what? Moles times mister. So there the moles is 2.04 times mister. What is mister? So what is the meter, which is here, which is 16 times 2. There 1 times 12, which is 32. This is 12. So 12, which is 4, which is 44. So times 44. What is the answer? Multiply. Sorry. Which is 2.04 times 44 is giving us 89.7. So it's giving us 89.76. So it is the same as 90 grams. Now we know that this is the theoretical yield for CO2, and the actual yield they have given us in the question, which is what already the actual, it was what, it was 70 of CO2, that is the actual yield. So now we calculate percentage yield, so which is percent yield is equal to what, actual, which is actual over theoretical, times so actual over theoretical times 100. So actual, what is the actual? So the actual, which was 70 over theoretical, which is 90, times 100. So the final answer is what? So 70 divided by 90 is equal to 0.77 times 100, that is 78, which is 78%. That is the percentage yield. So this is correct. So we have ended here. So for more information, buy the notes, summarized notes for percentage yield. Summarized notes, it costs 5 kwacha.